Hello students, welcome to the first part of correlation lecture series. In this first part, we'll be focusing on the basic things, the theoretical part of the concept called correlation. Especially we'll be focusing on the concept called correlation given by Carl Pearson. Now often it becomes important to understand relation between two or more things or objects or variables in our day-to-day life, personal or professional, that is work life. Things are interdependent on each other, they affect each other for their behavior or value. So if we are interested in understanding how one quantity or term or variable affects the other variable, that is change in one variable, how it is affecting the other one, then we are supposed to learn the concept called correlation. This is one of the important tool to understand the interrelationship between two or more variables. For example, if we are interested in understanding the concept called price and demand, you'll understand if demand increases, price will also go up. For example, if your income increases, most likely it will happen that your expenditure will increase. By how much amount is a different issue to discuss, different topic to discuss. But if your income is going up, is increasing, most likely it will happen that you will spend more amount of money on different heads. If your income goes down, then you are bound to decrease or bound to alter the expenses. So income increases, expenditure increases, income goes down, expenditure will also decrease. If demand increases, automatically price of the quantity or commodity will increase. So these are interrelated with each other. So we need to understand how they are affecting each other and whether there exists any relation between these. If yes, then up to what extent they are related and how they are affecting each other. Only understanding the relation or existence is not enough. So our job is to quantify this relation, and to quantify this relation we have got one tool with the concept called correlation. So let us try to understand first how to understand existence of correlation. So scatter plots helps us to understand this concept. Now if we plot the data for both the variables which are under study, we can understand whether any relationship exists between given two variables or not. Let us say we have demand for onion and its prices in the market. So if we assume that demand is plotted on x-axis and its price is plotted on y-axis, and if we refer the first plot, we can understand that, see here, the x-axis, which we are considering this horizontal line, refers to the demand of onion in the market, and y-axis, this horizontal vertical line, refers to the price of the same commodity, that is onion, in the market. And if you see the plot, these dotted lines indicates the values which are plotted against the demand and price. So if you move on right hand side of the x-axis, you will find that the demand is increasing, and if you move on y-axis on upwards, then you will find that the price is also increasing. So if you move like this, then we are moving on both axes, that is demand is increasing, price is increasing. So such plot where values are shifting from left bottom to right top in this scattered way shows existence of correlation. That indicates that the two variables which are under study are having some kind of relation, and it is positive. That means change in one variable, that is increase or decrease in one variable, affects similar kind of change in the other variable, that is increase or decrease. If demand increases, price will increase. If demand goes down, price may decrease. By what amount is a different issue to discuss. Okay, so if you consider the other graph, the second graph, you will find that a similar kind of graph plot, but in reverse order. That is, it is decreasing from left top to right bottom. So if price increases, if the demand increases, price, or if the demand of the commodity increases, the price may go up or down. So if it is going down, then we say there exists a reverse or inverse relationship between each other, and then we say it's a negative correlation. So we say there exists a correlation. So such graph which shows downward movement in such scattered way. If we consider the third graph here, where there is no particular pattern, haphazardly values are available in this plot. So we say it is the indicator that there is no relationship between given two variables. Weird example to understand this, but the best example. Let's say number of students attending a live session on YouTube and number of buses running in New Delhi. Any relation? No, it's a weird example. We can easily tell there is no relation between these two variables. In that case, you will get such plot. Or we may say number of students registered with one university in present academic year and number of people coming out for voting. Any relation? No. So such weird examples where there is no relation between given two variables, you will have such horizontal plot where values are scattered here and there and there is no fixed pattern. We say in such case there is no relation between given two variables. So to understand this, we have got types of correlation. Correlation refers to relationship, interrelationship between multiple variables. Now we can have types of correlation where it could be positive, it could be negative, and we have subtypes as well. So let us try to understand types of correlation with the help of these scatter plots. Now we have first scatter plot which shows that both the demand and price are increasing. Let's say onion prices, commodity, its demand is increasing, which is reflecting on x-axis, then price will also increase. If demand is more in the market, price will automatically go up. So we'll find that movement is from left bottom to right top. In that case, we say there exists a correlation and it is positive. Why positive? Rule says if there is a change in one variable, that is increase or decrease in one variable, if it is affecting a similar kind of change in the other variable, that is increase or decrease. If demand is increasing, price should increase. If demand is going down, price should also go down. If such similar kind of change is observed in both variables, then we say both are positively correlated. And as per the rule, we say this will be upward movement from left bottom to right top. Okay. Now if you go for the second plot, you will find that the movement is in reverse order, that is left top to right bottom, downward movement, right? If demand is increasing, maybe price may go down, or if price is increasing, demand may go down. In that way, you may understand where the change is in reverse order. They are deviating, both variables. If they deviate in different direction, opposite direction, then we say there exists a correlation and it is negative. That is, if increase or decrease in one variable affects opposite change, that is decrease or increase in the other variable, then we say both are negatively correlated. That means if first variable observes a change, that is increase in its value, and the other variable shows a decrease in its value, then we say both are deviating in opposite direction and hence reflects negative correlation. Okay, we have seen this no correlation part, but if correlation exists, then again we can have some separate different type of correlation. Let us go to the plot number 4, where movement is from left bottom to right top. But if you can see, all these values are clustered on or around this straight line passing through origin from left bottom to right top. So if you are able to reflect your data through such straight line, then we say the relation exists and is positive because it is increasing, moving from left bottom to right top, and specifically it will be a perfect positive correlation because your data shows trend in a straight line. So such plot is reflecting perfect positive correlation between given two variables. Now on the other hand, exactly opposite, if we go to the plot number 5, we can observe that the trend is exactly opposite to plot number 4, that is moving down from left top to right bottom, where values are clustered on or around the straight line close to each other. That indicates that there exists a correlation, but it is negative as the trend is moving down. But as they are moving down with a straight line, we can say that it's a perfect negative correlation. So positive, negative, perfect, negative correlation. So it is the indicator that we can have correlation in such a different way. Now only understanding existence of correlation between given variables or able to understand whether it is positive, negative will not serve our purpose. We must be able to quantify this relationship. We must be able to convert this relationship into number form. So how to quantify this relationship? To help us in this concept, in this problem, British biometrician Carl Pearson had given us this concept called coefficient of correlation. We call it by the name Carl Pearson's coefficient of correlation. There are many coefficient of correlation. First one, and for our syllabus, is Carl Pearson coefficient of correlation. What Carl Pearson says that he indicated this correlation coefficient by the alphabet small r. He said that r will take value from -1 to +1 strictly, including these two values. So range of r, that is coefficient of correlation, varies from -1 to +1, that is in between this range. It will not go beyond this range. Now what does it mean? Correlation, if it exists, it will take value, its coefficient, that is quantification, will give us values from -1 to +1. As there are two signs involved, minus and plus, it indicates that there could be a negative correlation, there could be a positive correlation, and in between these two, we may have a 0 as well. That indicates no correlation. Okay, so let us try to understand with the help of these plots again. If we refer to the first plot, we can understand that there is a positive correlation, there exists a positive correlation, because we can see upward movement from left bottom to right top. That is, both variables are deviating in same direction. Increase or decrease is visible in both variables, similar kind of change. In that case, we say positive correlation. So obviously the coefficient of correlation where we are quantifying this relationship will have a positive value. So we say R, that is coefficient of correlation given by Carl Pearson, is strictly positive, non-zero, greater than 0. Now if we go to second plot, where we are able to see exactly reverse relationship where movement of values is from left top to right bottom. That is, variables are negatively correlated, having variation or change observed in reverse direction. So if value of one variable increases, the value of second variable decreases, goes down. Okay, so here we say negative correlation. So obviously your coefficient of correlation given by Carl Pearson should have a negative value because we are quantifying the relationship. If it is negative correlation, the coefficient of correlation R will have a negative value. That indicates it should be less than 0. Therefore, coefficient of correlation R will have value less than 0, that is negative value, in case of negative correlation. Okay, now in case of the third plot, if we refer, where we have a horizontal plot, haphazardly values are scattered here and there, where we say there is no correlation between given variables. There exists no correlation. In that case, we say the coefficient of correlation R given by Carl Pearson will have its value as 0. 0 indicates no correlation, absence of correlation between given two variables. Okay, now if we refer the fourth and fifth plot, we get some other information from these two. Now fourth plot is for positive correlation, fifth is for negative correlation, but specifically we are writing here that it is perfect positive correlation. What does it mean? If your coefficient of correlation is exactly +1 with no approximation, then we say we have a perfect positive correlation. Our coefficient of correlation will carry value exactly +1, where values are moving in with a straight line from left bottom to right top. Perfect positive correlation. So value of R, coefficient of correlation given by Carl Pearson, will carry value as +1, exact +1 without any approximation. If you refer the fifth plot, where we have shown negative correlation, we are writing perfect negative correlation because values are moving down from left top to right bottom with a straight line. So as it is perfect negative correlation, it will carry value of its correlation coefficient as -1. So correlation coefficient given by Carl Pearson R will carry value as -1, exactly -1 without any approximation. So we can understand, if your correlation, if it exists and is positive, correlation coefficient, where we are quantifying the relationship, where we are measuring the relationship in number form, will carry positive value. When it is negative, it will carry negative value. When it is positive but perfect positive, it will be exact +1. When it is perfect negative correlation, it will be carrying value exact -1. No need to say, when we have a positive correlation, value of R is greater than 0 but less than or equal to +1. Same way, when we have a negative correlation, value of R, coefficient of correlation, is less than 0 but up to -1, not beyond -1. So we can say that correlation coefficient given by Carl Pearson takes values from in the range -1 to +1 strictly, including these two values. So if you are getting any value for coefficient of correlation, where you are quantifying the relationship, where you are measuring the relationship, correlation in number form, if it goes beyond -1 or +1, then the answer is wrong. It should be strictly within this range, including these two values. Okay. Now Carl Pearson has given us a formula to measure this relationship in number form, that is coefficient of correlation, R. That is covariance between two variables divided by product of their standard deviation. So covariance of between x and y divided by product of standard deviation of variable x and standard deviation of variable y. So this formula gives us the correlation coefficient value, which we will be using to decide for or to take decision for our day-to-day life, in day-to-day situations, or in business life for taking decisions. So your decisions where you are supposed to correlate, where you are supposed to identify whether a particular thing is a result of some change in some other concept, then we can say correlation will play an important role. For example, if you are interested in, let's say you are working in a particular company, a multinational company, and you are responsible to take decision over spending money on advertisement of your product. Let's say you are manufacturing these whiteboards and your job is to decide whether to increase your expenditure on advertisement so that your aim, that is more sale, will be attained. You will be able to sell more units and will be able to attain more profit. So you have to understand that whether a relation exists between expenditure on advertisement and sales figures. Whether sales figures are getting affected because of your increase or decrease in advertisement budget, then better thing will be to understand this first using correlation concept. And to predict, we will be having another concept which we are going to learn in another series called regression, where we can predict values. So here we will be focusing on correlation, where we are interested in understanding relation between two variables, whether one variable affects the other variable for its value or change in its value. So in this first part of correlation, we have gone through meaning of correlation. Then we have used scatter plots to understand whether correlation exists between given variables or not. What is the pattern which indicates existence of correlation or non-existence of correlation? If it exists, then types of correlation, whether positive, negative, if positive, whether it is perfect positive, if negative, if it is perfect negative or not. Then we have also seen the concept called coefficient of correlation given by Karl Pearson and its range of values, where we quantify the relationship in number, that is, we convert the relationship in number form. And it is said that coefficient of correlation given by Karl Pearson takes values from -1 to +1, including these two upper limits, -1 and +1. And we have also seen the formula for coefficient of correlation given by Karl Pearson: covariance between two variables divided by product of their standard deviation. So in next part, that is part 2 of correlation, we'll be focusing on how to understand this formula for coefficient of correlation and how to quantify the relationship between given variables. We'll be solving few sums using the formula given by Karl Pearson. Thank you very much for attending this online lecture, YouTube lecture on correlation part 1. Please do subscribe my channel and like the video so that you can get notifications for new release. Thank you.